All right. So we have those products. The next step is, guys, I did not introduce this vocabulary word. All right. We're now going to write what is called a molecular equation. A molecular equation is nothing but writing all the formulas and balancing the equation. We have done this, we just haven't given it a name. Does that make sense? What are we going to write? The molecular equation. And what is a molecular equation? So first off, I need to write the formula for calcium bromide. Is calcium a +2 and bromine a -1? Bromide a -1. Is that correct? So the formula will be CaBr2 plus, correct? Potassium is a +1, sulfate is a -2, it's K2SO4, correct? Giving me calcium sulfate, a +2 and a -2, so it's a CaSO4, plus potassium bromide is a +1 and a -1, so it's going to be KBr. Correct? So molecular equation must be balanced. Okay? So in order to balance this equation, I need to introduce a 2 here. Is that correct? The next step, do you see how it is multiple steps? And unless you get these steps right, you will not be able to write the net ionic equation. So you should be able to predict the products. You should be able to switch correctly. You shouldn't put 2 non-metals together or 2 metals together. Is that right? After you do that, you should be able to write formulas correctly. Is that right? The next step is being able to look up the solubility chart and stating the state symbol for each and every substance in this reaction. So I have, this is aqueous, correct? Did you get this as aqueous? This will be a solid. Is calcium sulfate a solid? Right? And the last one is aqueous. Now, if you do not have a comfort level with using a solubility chart, this whole 10-point question you will miss on the test. Does that make sense? If you are uncomfortable reading a solubility chart, you need to come into my class and get additional help. Is that understood? Were you able to find these state symbols on your own? All right. The next step is what we call the overall ionic equation. It's called overall ionics. Again, it's a new vocabulary word. Write that down in your notes sheet of paper, in your warm-up, so that you, if such words are thrown, you know what that means. As the very word says, ionic, all right, you now need to have ions in your equation. Does that make sense? When will you have ions? When anything is aqueous, it dissolves. Is that what it means? Dissolving, how does the process of dissolving even happen? It's because the compound is now breaking up into its ions, which are much smaller in size, correct? And you can't see them anymore in the liquid. Yes or no? Because of the size of the ion. They're not packed together anymore. They're separated. They're so tiny that you think, oh, they don't even exist in water. But they do. Is that right? Especially if they're colorless. Is that right? You take salt, dissolve, unless you taste the water, you don't know it contains sodium and chlorine ions. Yes or no? So you break them apart. So you will break it into a calcium +2. I need to see the +2. If anybody just writes a Ca there without a +2, I'm going to give you a 0 for that, because when you write Ca, it means calcium metal to me. And a calcium metal is not soluble. Right? It's sitting there. Yes or no? It's a solid. but a calcium plus 2 is a dissolved ion. There is a lot of difference between calcium metal and calcium ion. They are different. I can put Na plus into my mouth. Can I put Na into my mouth? It will burn and I'll die. So do you see the difference between writing Na and Na plus? Similarly, there is a lot of difference between writing Ca and Ca2 plus. And that means a lot of difference. And now how many bromide ions? You need to put the 2 in front. You cannot write Br2. Br2 is a gas. If you write this as Br2 minus, I'm like it's already neutral as a gas. How the heck did it gain an additional electron? How is it an aqueous substance? Whenever I write these formulas in chemistry, remember, they are different things. When you write formulas incorrectly and tell me things, then you can't mix up Gaurav with Mohit. They are different. Are you trying to tell me they are the same? Do you understand? I will not accept that as an answer. So that is 2Br minus plus, it becomes a 2K plus an SO4 minus 2. Did anybody have trouble with breaking up the ions? Do you understand the way in which they should be broken? Now, let's go over to the product side. Can you break a solid? No. I see that in the solution. Yes or no? If it were ions, would I be able to see them? No. So you should not break up a solid. A very common mistake. It's like monkey work. Kids notice, the kids learn how to break up ions without any thought. They keep breaking it up. Alright? Just because you know to break, you don't break it up. You really have to look up the state symbol. Is that right? And that is 2K plus 2Br minus. Okay? Now, ions that are common to both sides are called spectator ions. Did I introduce this vocabulary word last class? Alright. So ions that are common are called, where should we write this down? Maybe in the bottom or somewhere. Maybe you can make a note and say ions that are common to both sides are called spectator ions. What are they called? Spectator ions. It's like you being a spectator at a game. Are you actually playing? No, you're just standing there and watching. Does that make sense? The ions here are just there in the solution. Do they actually participate in the reaction? No. Do you understand the meaning of the word spectator? Alright? A spectator is a person who observes, right? So these ions are just there. They are not actually a part of the reaction. Alright? So what are these spectator ions? And let's get rid of them because we want to see a final reaction. Do you have 2Br minus on both sides? Who are you working with me? Do I always talk about active learning? You're here spending your time. Why don't you utilize it positively for yourself? Why do you want to do double study? You don't listen in class, and then you have to go home and teach yourself everything. Please listen. Please value your own time. Alright, so do I see 2K plus is common on both sides? Can I cancel Ca plus 2 with CaSO4? Can I do that? No. One is a solid, one is an ion. So finally, I write my net ionic equation. Are we good? And that is Ca plus 2 plus SO4 minus 2 should give CaSO4. Now guys, Here is a little clue, tip, hint. Alright? If you have a 2Br minus, you should have a 2Br minus on the other side. If you have just one Br and a 2Br on the other side, in a double replacement reaction, you have made a mistake somewhere in writing the formula. It should cancel beautifully. Does that make sense? You must have made a mistake with formula writing if it does not cancel and give you the net ionic equation that you want. Be aware of that. Okay? Let's go to the next one. Yeah.
I have a question. Like, if you were breaking apart, like, something from the molecular equation to the overall equation, and it was a diatomic element by itself, would you write a 2 in front of it?
If you're writing aqueous underneath it, if it's a diatomic element, other than iodine, bromine is a liquid, iodine is a solid, you're writing aqueous.
Okay.
When I write aqueous underneath it, what I'm trying to say is it's a substance dissolved in water. Does that make sense?
Yeah.
Ions dissolve in water. Diatomics are liquids and gases. No. There's a difference between writing Br2 and writing Br minus. If you say, let's take chlorine, which you can relate to more easily. Cl2 is chlorine gas. If you inhale, you'll start coughing. Cl minus is in your salt that is edible, and you eat it. There's a lot of difference between Cl2 and Cl minus. Cl minus is aqueous. Cl2 is a gas. Don't mix them up. Recognize that they are different from each other. Do you understand why I get so upset when kids do this? Alright? And I am required to take points off because that is the fundamental understanding in chemistry, correct? Do you know the difference between Cl minus and Cl2? Okay. Let's look at the next one. Magnesium. Does it say it's just magnesium? If I just mention magnesium, Natalie, what does it mean? It's just a metal. Is that right? Just magnesium means it's a magnesium metal. So if I'm going to write my molecular equation, can I write Mg as Mg plus 2 or Mg2 with a subscript? Can I do any of that? Can I ever write Mg, just I'm going to erase this, can I write Mg as Mg plus 2? I think kids do this all the time on my paper. Can you do any of this? You're telling me magnesium is a diatomic gas. Are you being serious? Or you're telling me it's dissolving in water when you write Mg plus 2. I'm not telling you it's an ionic compound. A metal won't dissolve in water. Yes or no? You work with magnesium strips. Will a metal dissolve in water? Most don't. Yes or no? So you just write Mg. There's an ocean of difference. If you write any of this for magnesium, I'm going to get mad at you. Or I'm going to take points off. I'll be mad when I'll be grading. All I can do is circle it and say no. Right? Okay, so that is magnesium plus, it says tin sulfate. Is this now an ionic compound? Correct? Tin 4 sulfate. Do ionic compounds dissolve in water? Do ionic compounds dissolve or they don't dissolve in water? Depending on the solubility chart, you can figure out if they're soluble or not soluble. Yes or no? So right now, let's write the formula for tin 4 sulfate. This is a plus 4, sulfate is a minus 2. How many times am I multiplying the sulfate side? 2. So what is my formula for tin 4 sulfate? 2. Correct? Now, what is the type of reaction? If I mix magnesium with tin for sulfate, what is the type of reaction? It's a single replacement reaction. In order to know if a single replacement reaction will take place, what do I make use of? The metal activity series. So there are two metals here. Which is the more active metal? Magnesium is more active. So will sulfate prefer the company of magnesium? Right? Will the reaction happen? Yes. The reaction will happen. So I will get magnesium sulfate. Why do I write MgSO4? Why do I not write MgSO4 within brackets and a 2? Well, you wrote it like that on the other side. Why are you writing it like this on this side? Why? What is the charge on magnesium? What is the charge on sulfate? What is the formula for magnesium sulfate? If you write MgSO4 2, magnesium can give only 2 electrons. How did you make it give 4 electrons? Against nature. Won't happen. Okay? Plus, what stands out separately? 10. Okay? Let's balance the equation. The sulfate has to be a 2 and the magnesium has to be a 2. The equation is now balanced. So the intent is to write a net ionic equation for this reaction. Is that right? What did we say? Magnesium is a metal. Is it a solid? Correct? Is tin sulfate aqueous or is it a solid? Look up your solubility chart. What do you know about sulfates? Aqueous. So I know that this is aqueous. Look up magnesium sulfate. What do you know about magnesium sulfate? It's aqueous. Did I write this as tin plus 2 or SN2 or anything like that? So what is, if I just write SN, what is it? It's a metal. It's a solid. Now I have to write the overall ionic equation. So solid is a solid. It's going to remain as it is. Is that right? Magnesium is a solid. So I'm just going to write it as 2Mg. I'm not going to do anything with it. Plus, is that aqueous? What do I do with anything that is aqueous? Break it up. So what will Sn in this case break up into? Plus 4. Very good. Plus, how many sulfate ions will it release? 2. 2 SO4 minus 2. Giving me magnesium sulfate is aqueous. Will it break apart? Are we writing this down? Are you writing this down? As I write, you write? It's 2Mg plus 2. Is that right? Does the 2 distribute? How many sulfates will I get? How many sulfates? Will I write 1 SO4 minus 2 or will I write 2 SO4 minus 2? This 2 distributes. Yes or no? So it is plus 2 SO4 minus 2 plus just Sn. Correct? Right? Is it just Sn? Alright. Now we are going into the net ionic equation. We want to get rid of the spectator ions. We just want to know what's actually happening in the reaction. What are the spectator ions in this equation? The only spectator ion is 2SO4. If I find kids canceling 2Mg with 2Mg2 plus, that means they don't know the difference between an ion and a metal. Right? They don't know the fundamental difference between what is a solid and what is dissolved. Can you dissolve something that's a solid with something that's aqueous? No. So the net ionic equation is 2Mg plus SN4 plus gives 2Mg plus 2 plus Sn. Can cancel Sn plus 4 with Sn. Right, Natalie? Are we writing that down? Okay. Let's go on to the next few reactions. Alright? How do you write sodium? If I just have sodium, what is the symbol? Will I write a 2 or a plus 1 with sodium? No. Na. I'm writing my molecular equation, by the way. What is my oxygen written as? O2, because it's a diatomic element and it is a gas. If I have a metal and a non-metal, what is the type of reaction? Synthesis. All right. What will a metal and non-metal combine and make? An ionic compound. Is my formula NaO2? Is my formula NaO2 on my product side? Why isn't it NaO2? It's a metal and a non-metal. Are you looking at a metal activity series or solubility chart for a synthesis reaction? Do we use any of that for a synthesis reaction? So is my product NaO2? Why? Yes. Very good. It's now giving and taking electrons. Alright? Na is a plus 1, oxygen is a minus 2, which means what is the final formula? Na2O. It's Na2O. Ruby also needs net ionic equations for her AP chemistry class, right? Let's do it together, Ruby. What is the state symbol for sodium? Solid. It's a metal. What is the state symbol for oxygen? It's a gas. What is the state symbol for an ionic compound? Well, in this case, the metal sodium would have already reacted with water if you put it in water. So there is no liquid here at all. Only if the ionic compound is dropped into water, it will dissolve. Is that right? The single replacement reaction here will take place in solution. Alright? Synthesis reaction, do you remember burning magnesium in the lab? Do you remember taking a strip of magnesium and burning it? Do you remember that? Did you have any water there? No. And let me remind you of a single replacement reaction that you actually did in the lab. Did you have copper chloride blue color solution? Do you remember that? Do you not remember that? I gave you a watch class. I may have some of it. Let me bring back memories because they need to relate to what they're learning. Okay? So, I think it's here. Alright? So, do you remember using this liquid and having an aluminum strip and ripping apart the aluminum strip and dropping it into a watch glass? Do you remember that? There was a watch glass. Is this aqueous already? This was a single replacement reaction. This is copper sulfate, but the copper sulfate is dissolved. Does that make sense? And the metal was a solid. Yes or no? When you ripped it and put it into solution, what came out? The copper metal will come out, which is exactly the reaction type B. Magnesium was like the aluminum strip. Tin sulfate is your liquid. What remains in solution is your ions after that, and the metal tin got formed. Does that make sense? Okay. So that was that. And let's move on. And so when you go to synthesis reaction, it's like burning your magnesium. Okay? So you don't have any water there. So you will not say, oh, what did I do with this? Okay, here it is. So it's going to be a solid. All right? Guys, can I break anything apart into ions in a synthesis reaction? Is anything aqueous? So the molecular equation is going to remain the same as your net ionic equation. Does that make sense? It's going to remain the same. Nothing is going to change. All right? This molecular equation is the same as your net ionic equation. Okay, yeah, let's balance that. So that'll be a 2. Is that right? No, 4. A 4 and a 2. Is that right? That's a 4 and that's a 2. All right, let's move on. Oh, this was on the lab test, and the number of kids who got that wrong. This is, how do I write the formula for calcium carbonate? CaCO3. I've just given you one single substance. What do you think the type of reaction could be? It's a decomposition reaction. All right? And it's just a, you remember working with a green colored powder in the lab? It's just a powder. Okay? Right now you don't look up the state symbol and you don't say it's aqueous. All ionic compounds, when they're not dissolved, are all solids. It's a powder off. Does that make sense? So then, what will it break up into? It is a polyatomic ion. It can break up. So carbonate is a -2 and it's an ion. Where can you find an ion? Where do you find ions? You can only find ions in water. Is that right? Yes or no? Can ions float away into air? No. All compounds have to be neutral. The number of kids who told me that it is calcium plus carbonate was a record number. I'm like, there is no gas called CO3. I don't know of a gas that's CO3. Yes, I know of a gas that is CO2. If that is a CO2, then what happened to my third oxygen? Where did it go? It's stuck with calcium. So my product is calcium oxide plus carbon dioxide. What is the state symbol for carbon dioxide? It's a gas. Calcium oxide, remember there is no water here. So calcium oxide is an ionic compound. Is that correct? What is the state symbol? Solid. And it's already balanced. And the net ionic is going to be the same as the overall ionic. You get this? All right. Carbon tetrahydride. CH4. Yes, Katie. Yeah.
Never mind,
Okay. Okay, Katie, and I'll tell you where your thinking is not going the right way. It's a covalent compound.
I was thinking I had calcium instead of
Okay. This is a covalent compound plus oxygen. Well, you don't know this information, so I'm going to give you this information. carbon hydrogen containing compounds. We come across a lot of them in our everyday life. Alright? If carbon becomes C, if carbon is from anywhere from 1 to 8, the number underneath carbon right now is what? 1. If carbon goes anywhere from 1 to 8, it's generally a gas. If carbon goes anywhere from 8 to 16 or so, it's a liquid. Above 16, it becomes a solid. Okay? So, when we have natural gas, which we use in our Bunsen burners, that substance is a gas. Is that right? And it can be liquefied, the carbon chain increases, right? And your airplanes, your gas that you pump into your car are all greater number of carbon chains. Do you understand? But then if it exceeds 16, you again burn the same thing in the form of candle, which has wax. Is that right? Will wax burn? That's because it's a higher number of carbon atoms. They're all carbon hydrogen containing substances that can give us, that can combust. Does that make sense? And when they combust, they release a lot of energy. And we use them as our energy source. Now, so we said this is a gas. We said that is also a gas. What is the type of reaction? What is the type of reaction? It's combustion. What are the products of a combustion reaction? Carbon dioxide and water. All right? What is the state symbol for carbon dioxide? What is the state symbol for water? You can say it's a liquid, you can say it's a gas, you know, it can be steam, it can be water. Right? So then, what is, are you guys with me? What are we talking about? Okay.
You know that wax.
Yeah. No, I mean, you know enough to know for a second. That's exactly.
It's the hydrocarbons. Okay? So is there any difference between a molecular equation and a net ionic equation here? No. So it's going to remain the same other than the fact that you have to balance it. And the oxygen will be a 2. Is that right? So it's going to remain the same. Are we good with writing net ionic equation for any type of reaction?
Yeah.
Okay? All right. We're going to move on to a heavy topic now. All right? And I need my kids to really focus and work. If you work, stoichiometry is really, really easy. If you don't work in class, stoich can be difficult. Can I have kids work through this sheet? Let me give you 10 minutes. Do it on your own, and then we'll come back and discuss a few things. Can I give you 10 minutes? Whose thing is constantly clicking? Is it mine? Let me find out if it's mine. So loud. Can you do these problems now? I like that you're discussing, but we need to move on. What? Okay.
Yeah.
My daughter finally woke up to what happened in our school yesterday. Okay. Yeah. I've given you 10 minutes. Guys, you're working on this sheet of paper. Caroline, this sheet of paper, please. Guys, you see the sheet that's projected? You should be working on this. Let me also make an answer key. Let me see how much it takes time. How much time it takes.